carrying on with 18.3, page 276, question 4. This is as grade A or A star as you can possibly get. It's an awkward little diagram. It's got says here 4 3-meter bamboo canes are used to make a support for growing some runner beans. So these are 3 meters each. All these A, B's, A, C's, all 3 meters. And each end of the cane is stuck in the ground at the corners of a square. So that is a square. It's a 1 meter by 1 meter square. We're going to grow some runner beans. That's nice. The top ends are tied together, so that's tied up so it doesn't fall apart. Calculate angle BAC. BAC. So BAC. So once that part's going blue so we can see it. Once that part's BAC, that right there. Now, the way I'm going to help you do that is if I draw this little triangle here in front of you using this facility, then I'm doing part A, by the way. So if I work here, and what I'm doing, I'm giving you a flat two-dimensional look at what's happening here. So here is A at the top, just there. Down here is the C, and down here is the B. I know this is 3 meters long, and I know the other side is 3 meters long because all the poles are 3 meters, all the canes rather are 3 meters long. Now I want the angle B, so what does it say again? BAC, BAC, wants that angle there. I know this is 1 meter across the bottom there. I've got an isosceles triangle, can't do any trigonometry with that, so what I'm going to do is just drop a little perpendicular here in blue from top to bottom. No, let's go black. From top to bottom I've got myself a lovely right angled triangle, as you can see, and there it is. So what have I got? I've got a 3, I've got a 1, which makes these 0.5 meters each, doesn't it? Okay, splitting the 1 in half, get half each side. So I can now work with a triangle. Now I can't work out the angle BAC directly, I can work out this part only, call it angle X degrees if you like, and then when I get the answer to X I can multiply by 2, get angle BAC. So here we go. How do we work out angle X? What have I got? Well, I've got hypotenuse for a start. Now if you think very carefully, what we've got here, we have the angle and the opposite side shown. So really, even though this is along the bottom, you've got to see that this length here of 0.5 meters is opposite the angle. So I've got the op and I've got the hype, which means using op and hype I need to use sine. So here I go. Sine X, this is again doing part A, sine angle X. I've already defined X in my picture, by the way, so I haven't got to have a song and dance about what it means. I've just defined it as that part only. So sine X is defined as opposite, which is 0.5 meters, divided by the hypotenuse, which is 3 meters, and therefore X is going to be whatever the shift sign to that is. So I've got 0.5 divided by 3, press equals, and now I'm going to shift sign him, and I have got 9.59. Well, I would call that 9.6 if I may. 9.6 degrees now, therefore X is 9.6, and look over here, I've got another X over here as well, so therefore BAC is 2 lots of 9.6 degrees, which is, what my calculator says now, times 2. Oops, forgot to times it by 2. So 2 times 9.6 equals 19.2 degrees or thereabouts. Okay, 19.2 degrees, and that's my answer for that. That was really easy. Let's just do B down here. I think this is quite involved actually. Now B says calculate angle BAD. Lovely. So let's just get rid of that. That's in the way now. Now, quite difficult to represent this. BAD. I've got to span right across there and get that angle. So let me try and draw you what I've got to do. I have to draw it in yellow here really, using this facility. So, like I did up here with part A, got to keep it smallish, otherwise I don't get space to get it all done on one bit of paper. Right, that's quite tricky, isn't it? So I've got A up the top, I've got B down here, and I've got D down there. Now I know that AB is going to be 3 meters as is usual. I know that AD is also 3 meters. Now I need to know to get a proper flat triangle in 2 dimensions. I need to work out the length D to B, which is what I've got here. Now look very carefully. I know that if I got 1 metre across here from B to C and 1 metre across there from C to B, because I know it's a square base, I can calculate carefully the length B to D using Pythagoras. Alright, and this is the triangle I've just drawn in yellow here, ABD, and ultimately what I'm looking for is angle angle BAD, so angle bad. I want that one right there. Okay, A, right. So that's that. Now let's work out BD. Let's using Pythagoras. Well, 1 and 1 are both the two shorter sides, because this is like the hypotenuse. So if I do a quick Pythag up here, this is what I'm going to do. So let's call that BD, or DB better still. That is 1 squared plus 1 squared square rooted. So 1 squared and 1 squared is basically 2, and the square root of 2 is very unpleasant. Well, let me just write it in. It's 1.4142. I do not want to round it off at all. I really don't want to round it off. If you round off every single step, and there's several steps in the calculation, your final answer will be out by quite a bit. So I've learnt that, ages ago, not to over round for intermediary steps. So BD is 1.412. So let me write it in. 1.4142 rather. Okay, so I've got that. I've got myself a triangle with a base of 1.4142. Right, now I think we ought to be dropping our perpendicular again. Let's just take a black line and do this. Cut it down the middle. And so what I've got is a right angled triangle again. And here she is. Right angled triangle. I've got a 3. And I've got a 1.4142, but I don't need the entire base, I just need half of it. So that's going to be 1.4142 divided by 2. So 1.4142 divided by 2, and that gives me 0.7071, and I'll leave it like that, okay? So what have I got here? If I want to work out angle BAD, I can work out half of it like before. So I want to call this angle, I don't know, I can call that x degrees, and the other half will also be x degrees. I just add on the 2 x's and I've got BAD sorted. So what have I got then? Exactly the same as before. That's opposite the angle, and so that's the op. This is the hypotenuse, the longest length, hype. So I've got op and hype, which is sine again. Let's try and fit it here. So sine of angle x degrees, the new x now because I'm working in section B or part B of the question, is going to be the op, 0.7071 divided by the hype, which is 3. I won't press the equals button now and just give you a long, probably non-terminating decimal. I'm just going to say therefore x degrees is going to be whatever the shift sign is for that. 0.7071 divided by 3 is horrid. And then I want to shift sine that, and I get 13.6 degrees, 13.63, so 13.63 degrees. Therefore, what do I want? Bad. Therefore, BAD, hopefully it will fit nicely here, equals 2 lots of 13.63 degrees, and hopefully my answer will fit just there, times 2, doink, 27.26. Now I'm going to round it for real and leave it. 27.3 degrees, my final answer. And that's a lovely 3-dimensional question involving trigonometry and a bit of Pythag. It's probably as hard as it's ever going to get. That's a lovely question. And last question will be question 5, just to finish off this section, which is incredibly easy compared to what we've just done. I mean, the diagram's drawn beautifully for us, and it's working blue. It says a shed has a base that measures 6 meters by 2 meters, so it's 6 by 2 across there. The roof slopes, so the front edge is 2 meters tall, so that's 2 meters tall at the front, and it's obviously bigger at the back. Now the slope is 30 degrees. Let me just draw that in blue. So that's 30 degrees. You can see a little triangle there, I'm sure. Look carefully where my pen is, and the camera should zoom in because that's where I'm working. Calculate the height of the back of the shed. Well, look, I know this part from here to here is 2 meters, is it not? Because it's the same height from there to there as it is from there to there, and so that's also 2 meters from the dotted line to the bottom where the floor is. So my job really is to work out that little bit and then add on the 2. So what have I got? I've got a very simple triangle. That's the dotted line there. There's my 30 degrees. I know the base of this triangle, or the adjacent side, is also 2 meters. So it's 2 meters across there, 2 meters across there. So it's 2 meters. And therefore I'm now got to work out mystery length x. What have I got? I have got the opposite, which is what x is. And I've got the adjacent length. And as you may recall now, you should know, you've got to learn them, that op and adj make tan. So let's just go back into yellow. So tangent of 30 degrees is defined as the opposite, which I've called x, divided by the adjacent, which is 2. Therefore, the length I'm looking for, x, is going to be, take 2 over and multiply, 2 lots of tangent 30 degrees, pick up my machine and do it. So 2 tan 30. Please note, we're not shift tanning. I'm not working out a mystery angle. I've got the angle. So I want the tangent of the angle, which is 30, then multiplied by 2, and that gives me 1.14. So 1.154 rather. Leave it like that. 1.15 meters, because the question's in meters. Therefore, how tall is it? So what's the height of the back? It's going to be 2 meters plus the extra little bit, the x bit, 1.15, altogether then 3.15 meters at the back. And that, friends, is section 18.3 done. Certainly with excuse me, certainly with the older scheme, there are a lot more practice questions than this, and of course if you need to do more, I'll pull out the older books and there'll be, I don't know, at least a couple of pages of these 3D things, you know, different scenarios. But that's it for now. I've got to go with what's in the book. That's what we're working from, so I'm happy to leave it as is. Alright, see you soon in the assess.